Hey guys, welcome again to the Maths Club. If you are just joining us, we are welcome to have you. Don't forget to subscribe to our channel, like our videos, comment if you have any question, and hit the notification bell so that anytime we post anything, you are the first to know. And if you're a returning viewer, welcome back again. We start looking at mensuration, another mensuration, we're looking at length and perimeter. In the previous video to this, we looked at how to find length of sides of a triangle using Pythagoras theorem, sine rule, cosine rule. In this particular video, we're looking at circles. So how do we find length of arcs? How do we find length of chords? How do we find perimeter of a sector and perimeter of a segment? So let's get started without further ado. First thing is that we need to know the parts of a circle. Before you know the length of something, you need to know what exactly does that thing consist of. First thing you need to notice is that there is something called the center. So when you have a circle, there is something that the circle revolves around. It revolves around the center. So the center is the point within the circle from which all points on the circle are equidistant, meaning that every point on that circle is the same distance from that center. So it's often denoted by the letter O, something like this. So this middle here is the center of the circle. The second part is the radius. So what is the radius? The radius is the line drawn from the center to any point on the circle, and is denoted by R. Let's say picture. So you can see this is the center here, right? And we are drawing a line to touch any part. So it could be here, it could be here, it could be here, it could be here. Any line from the center to any point on the circle is the radius, and is denoted by small letter R. So the next point is a chord. So what is a chord? A chord is a line segment connecting any 2 points on the circle. So you can see that if I had a line from here to here, from here to here, from here to here, from here to here, as far as connecting 2 points on the circle, it is a chord. That leads us to diameter. So we said any line joining 2 points on the circle is a chord. So this one, the diameter is the longest chord in the circle, and it's passing through the center. So the line that connects 2 points and passes through that center of the circle. So if I had something like this, as far as passing through the center, this is the center. If I had something like this, passing through the center, or like this, or like this, that chord is the diameter, and it is the longest chord in the circle. We said something that a line from the center to any point is a radius. So this line is from the center to this place, that is one radius. It's from the center to this place, one radius, and it's a continuous line. So of course it's going to be R plus R, which is 2R. That's why they say the diameter is equal to the 2 times of the radius. Next thing we need to notice is the circumference. What does circumference mean? So circumference is just saying you are going around, all around, right, the circle. So circumference is total length around the circle. So if this is my circle, and I start from here and I go round that circle, I've gone round the circumference. So it's total length around the circle. It's calculated as 2 pi r or pi d. This is something I just need to know. You know, we said that 2r is equal to d, right? So it's either you say 2 pi r or you say pi d. So you have your circle, and like I just don't mind my circle here. This circle needs to it needs to undergo some healing, right? But this one here, this is a good circle. So if I go round it, that total length is the circumference. That takes us to the length of arc of a circle. So an arc is just a portion of the circumference. So this is the circumference, total circumference. So if I wanted to just take just the length from this point to this point, right, that is an arc. And this is a minor arc because it's just a smaller one. So it is the minor arc, and this one outside here is the major arc, just like you can see here. So this one here outwardly, this outward one is the major arc. So it says for any circle with arc PRQ, PRQ is the minor arc, and PSQ is the major arc, right? We can find the length of arc to be theta over 360 times 2 pi r. So if I wanted to find the length of arc for this small one, I'll use the smaller arc, which is this guy here, which is this theta, or I can say theta 1. But if I wanted to find the length of this bigger side, which is like the major arc, I will use theta 2. Of course, we know that the angle all around a circle is 360 degrees. So if this is like, let's say 100 degrees, this outside here will be what? 360 minus 100, and I'll give you 260. So this 100, this 260. Let's see some examples. Example 1 states that in the diagram, O is the center of PRQ, radius is 3.5 centimeter, and the angle of POQ is 50 degrees. Take pi to be 3.142 and then calculate correct one decimal place the length of arc PQ. Let's see the image. So we're told that the radius R is 3.5, POQ is 50 degrees, this inside one. So what this we said, we should find the length of arc PQ, which is like the minor arc. This taken from WAEC 1998. Let's solve it together. So we know that our formula for length of arc, first thing I need to do is write the formula. There is a mark for it. Length of arc is theta over 360 times 2 pi r. And let's look at it. Why is this formula even times 2 pi r? We said that the entire circle is 360 degrees, right? So we're just finding the length of a portion of it, of this portion, of just this portion that this portion covers, because the entire circle is 360 degrees, but for the length of just a small portion, that's why we're saying that small angle all over the total angle, which is 360. And we said the circumference of a circle, that is total length of the circle, is pi d or 2 pi r. So that small percentage times the total length, which is 2 pi r. This is a simple application of ratios and proportion, where you want to find the length of something small out of the length of something big. So that small angle all over the total angle, which is 360 degrees, times the total length of the circle will give the length of this small arc. Great. So that will be 50 degrees all over 360 degrees times 2 times pi times radius is 3.5. So of course you should have, I think most of the questions will say you should write the given, right? I think there's mark for this. So the given is your theta is 50 degrees, your pi is 3.142, and then your r is 3.5 centimeter. Always put the units. So let's replace. That will be 50 over 360 times 2 times 3.142 times 3.5, and this will be equal to, so I'll just punch everything to my calculator, 50 divided by 360, multiplying that by 2, multiplying by 3.142, multiplying by that 3.5. So that gives me 3.0547 centimeter. But the question is that we should do it to one decimal place. So which is approximately, what will it be to one decimal place? Great. So 3.1 centimeter. So this should be our answer to this question. Let's see if we're correct. Great. Example 2 states that in the diagram, O is the center of the circle, reflex XOY, this is the bigger one, which is the reflex angle, is 210 degrees, and the length of the minor arc, this is the minor arc, this is the major arc, is 5.5 meters. Find, correct to the nearest meter, the length of the major arc. So we're given the length of this minor arc, we're given the angle of the major arc, and we're told to find the length of the major arc. I want you to pause the video and try this out yourself. Welcome back. Let's solve this question from WAEC 2002 together. So there are two ways that we can solve it. I told you that this is just a simple illustration of proportion and ratio. Let me put my given and say angle XOY is 210 degrees. The length of the minor arc, so length of minor arc, which is XY, is 5.5 meters. And we're told to find the length of the major arc. So instead of me saying length of XY, because this one could also be XY, let me just say length of the minor arc. So this is what we're told to find. I told you that this is a simple case of proportion. So the smaller angle, or I would say the smaller arc, or I could just say the angle of the smaller arc will be equal to 360 degrees minus 210. I already explained why this is. This will give me 150 degrees, right? So I could say if 150 degrees has a length of 5.5 meters, then 210 degrees would have a length of x, and I can cross multiply. That will be 150 times x is equal to, 150 degrees times x is equal to 210 degrees times 5.5 meters, right? So if I divide both sides by 150, this will go, this will cancel this, so our x will just be, if I press that in my calculator, that will be 210 times 5.5 divided by 150, and that will give me 7.7 meters. But this I should find it to the nearest meter, so that will be approximately 8 meters. right? So our x will be approximately 8 meters. But if I wanted to solve it the longer way, which I think that you did, I would say, since I already have the angle of this, and then I have the length of this arc, and I know the length of this smaller arc from here, I could have said that the L is equal to theta over 360 times 2 pi r. And I could say for the smaller arc, my L is 5.5 meters, my theta is 150 over 360 times 2 pi times r. I don't know r. So if I cross multiply, this would be 360 times 5.5 is equal to 150 times 2 times pi times r. So I could divide this one by 150 times 2 times pi, and I'll divide this one by 150 times 2 times pi. So this will cancel this. My r will be equal to, so if I say 360 times 5.5, that will give me 1980 all over 150 times 2 will give me 300 pi. So let me see if I can simplify this any further. So if you do some divisions, this will give you 33 over 5 pi. You can see that I'm not using the value of pi as 3.142. So I know what my r is. So I could just see for the larger arc, our L would just be, our theta here is what, 210 all over 360 times 2 times pi times the r will be 33 over 5 pi. So pi will cancel pi, and then my L will be equal to, I'll just say 210 times 2 times 33 divided by 360 divided by 5. So that's 7.7 meters, or approximately 8 meters to the nearest whole number, right? So it's the same results, but if you look at it, this approach is actually, but especially if it's an objective question, you want to use the simplest method to get what you want. It's just a game of ratios. That's everything about all these lengths. So let's see if our answer is correct. So this is 8 meters to the nearest meter. Great. Example 3 says that an arc of length 22 centimeters subtends an angle of theta at the center of the circle. What is the value of theta if the diameter is 15 centimeters? We should take pi to be equal to 20 over 7. One thing you need to actually be looking out for is that this is in centimeters, this is in centimeters. Sometimes I might give you a trick question. One will be in meter, one will be in centimeter. You can find out how to convert from meter to centimeter. Just ensure that all of them are in the same unit before you solve. If they're not in the same unit, you have to convert. So what are we given? We're told that the L is 22 centimeters. We're told that we should find the value of theta if the diameter is 15 centimeters. We're told to take pi to be what? 22 over 7. So the next one, write an equation, which is L is equal to theta over 360 times 2 pi r. Or I could just use pi d, right? Since we are given d, so I'll just say pi d. So we know the L to be 22 centimeters. We don't know what the theta is, all over 360. We know our pi to be 22 over 7. We know our d to be 15 centimeters. So 5 here 3, 72. 3 here 1, 3 here 24. 2 here 11, 2 here 12. So what I have here is 22 is equal to 11 theta all over 12. So I could cross multiply and say 11 theta is equal to 22 times 12 times 7. So before I even multiply, I can divide both sides by 11. 11 cancel 11, 11 here 1, 11 here 2. So theta will just be equal to 2 times 12 times 7, and I will give you 168 degrees. Let's see if we're correct. Great, so 168 degrees. Now we enter into the next part, which is the length of chord of a circle. So the chord is any line that connects 2 points on the circle. So if we are given this chord here, we are agreeing with that this is the chord line PQ is connecting to this point. But you can see from this chord here, we can draw a line from the center to this point, from center to this point. This is radius, this is one radius, and this is the angle that is subtending, which is theta. So if we are told to find the length of chord, we're told that the length of chord PQ is equal to 2r sine theta over 2. But how did they arrive at this? Let's look at it together. So if this is our circle, the angle here is theta, right? If I draw a straight line from here down to here, it divides this theta into 2, such that this place here is now theta over 2, and this place here is theta over 2. It will divide it into 2 equal halves. So this is our r, this is our r. This is the chord here. So if I say this distance from here to here is x, and this distance from here to here is x. Remember, this one will not be r because this point is not coming from the center, it's coming from this place, so it cannot be r and it cannot be r. It's only anything coming from the center to any point on the circle that would be the radius. Any other thing is no longer the radius. So if this is x and this x, so let me take one part of it. So if I take one half, let me take this half. This place here will be my theta over 2. This place will be x, this place will be r. So from SOHCAHTOA, SOHCAHTOA, this is sine, this is cosine, this is tan. So for sine, it is opposite over the hypotenuse. So let's see. This is opposite. This is the hypotenuse. So these are the two sides that we have. We have the hypotenuse and we have the opposite. So it will be sine. But if I had the adjacent and the hypotenuse, I'll have used cosine. If I had the opposite and the adjacent, I'll have used tan. But the opposite and hypotenuse gives us sine. So sine theta over 2 will be equal to opposite, which is x, all over hypotenuse, which is r. So if I cross multiply, my x will just be r sine theta over 2. Remember, this x is just the distance of this one half, but this is one, this is another. So the total length, so let me just say if this is my c, which means length of the chord, so my c will be equal to 2x because it's the sum of this and the sum of this. So that will be 2r sine theta over 2. So this is how we actually got that equation. Let's see an example. Example first is that we should find the length of a chord which subtends an angle of 90 degrees at the center of the circle whose radius is 8 cm. This is taken from JAMB 2013. You might want to pause the video and just try this out yourself, given the formula that you now know. What are we given? We're told that the theta is 90 degrees. We're told that the r is 8 cm. We're told to find the length of the chord. So let's say this is x. So now the length of chord is equal to 2r sine theta over 2. So that will be 2 times 8 times sine 90 over 2. And this will be 2 times 8 times sine 45. So 2 times 8 is 16 and sine 45 is root 2 over 2. So I know that we've not touched this yet, but there are ways that you can find what all this sine 90 and all of that is. I believe that when we go further in the videos, we'll get to that point. So we're talking about angles. But if you press your calculator, you have this. So 2 here 1, 2 here 8. So the answer here is 8 root 2. Let's see if our answer is correct. So that will be option D. Example 5 says that we should find the length of the chord AB in the diagram shown below. And it's from JAMB 2019. We're given the options. So let's solve it together. Of course, now the length of chord is 2r sine theta over 2. But first off, what are we given? We're given our theta to be 68 degrees. We're given our r to be 3 cm. We're told to find the length of the chord. So that will be 2 times 3 times sine 68 all over 2. So that will be 2 times 3 is 6 times sine 68 all over 2. That will be sine 34. So let's multiply this. 6 times sine 34 degrees is going to give you 3.36 centimeter. So let's see if our answer is correct. Of course, this two decimal places. So let's see if our answer is correct. Okay, so the answer is in 1 decimal place. So if you have 3.36, so 1 decimal place, that will be what? Great, so 3.4 centimeter. That leads us to the next bit of this video, which is talking about perimeter. Perimeter of a geometric figure is the total length of its boundary or the sum of lengths of all its sides. So if I have something and I find the length of all the boundary and I add all of them together, that gives me the perimeter. So perimeter is crucial in real life application, so that when you want to fence a garden, you want to find out what is the total length of the sides. If I determine the amount of material needed for borders, just like when America was building that border, they will actually need to have found the length of the sides so they can properly plan. And if you're trying to determine the length of a path along a park, of course you would need the perimeter. So the first thing we're looking at is perimeter of a sector of a circle. For any circle with the center O and radius R, from which a sector POQ, so this is sector POQ here, this P, this O, and this Q. This is the minor sector, and of course this is the major sector. You can see the minor sector here and the major sector here. The perimeter of the sector is the sum of the two radii. Of course, this is sector here. What are the places that surround it? We have this radius here, we have the radius here, and we have this length of arc. So the perimeter is just the sum of the two radii and the length of arc. Makes sense, because this is just the surrounding. This is the guy here. So we just need to find the length of this place, and the length of the arc. We know how to find length of arc, and we know what radius is. So we can just say that the perimeter of a sector is just 2r plus L. R plus R will give it 2r, then plus L, which is the length of the arc, where our L is theta over 360 times 2 pi r. We just established that. Example 6 is that the angle of a sector of a circle of radius 10.5 centimeter is 120 degrees. We should find the perimeter of the sector and take pi to be 22 over 7. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. We're told that the r is 10.5 centimeter. We're told that the theta is 120 degrees. We should find the perimeter. So the perimeter P is equal to 2r plus theta over 360 times 2 pi r. So let's substitute. That will be 2 times 10.5 plus 120 over 360 times 2 times 22 over 7 times r, which is 10.5. So this will cancel this. This will be 3. This will cancel this. This will be 3.5. So we're left with 2 times 10.5, which will give us 21, plus 2 times 22. So we can even divide this. This is 7 here 1. This will be 0.5. So that will be 2 times 0.5 times 22, and that will give us 22. So our perimeter P is what? 43 centimeter, if you solve it correctly. Let's see if we're correct. Great, 43 centimeter. Example 7 now says that in the diagram, OACB is a sector of a circle center O and radius 5 centimeter. Given that AOB is 100 degrees, calculate square root 2 decimal place the perimeter of the sector. Take pi to be 3.142, and this take from GC 2002. So we have the R, we'll just find the length of the arc, and then we'll add all of them together. This is something that you can do. Pause the video and try it out yourself. Welcome back. Let's solve it together. We're told that the R is 5 centimeter. We're told that theta is 100 degrees. And we're told that pi is 3.142. So we know that P is 2r plus theta over 360 times 2 pi r. So let's substitute. That will be P will be equal to 2 times 5 plus 100 over 360 times 2 times 3.142 times r, which is 5. So 0 will cancel 0, 2 will cancel one of these, this will be 18, 2 will cancel this is 5, this is 9. So this is 2 times 5 is 10 plus, so 5 times 3.142 times 5 divided by 9, this gave me 8.728. So 10 plus 8.728 will give you 18.728 centimeter. But it's also find 2 decimal places. So these are approximately 18.73 centimeter to 2 decimal places. Let's see if our answer is correct. Great. Example 8 now says that a rope of length 18 centimeter is used to form a sector of circle of radius 3.5 centimeter on a school playing field. What is the size of the angle of the sector correct to the nearest degree? I want you to pause the video and try this out yourself. Welcome back. Let's look at it together. Solve this. First is that I need to know what are we given. We're told that the perimeter is 18 centimeter, radius is 3.5 centimeter, theta is unknown. So what can we do? Let's now label it. So this 3.5 centimeter, this 3.5 centimeter. We're looking for theta. So our perimeter is just 2r plus theta over 360 is 2 pi r. Theta is 18, r is 3.5 plus theta over 360 times 2 times 22 over 7 times r, which is 3.5. So let's simplify. So this 18 is equal to 7 plus 2 times 22 times 3.5. Divide this by 360 and divide this by 7. 0.061 theta. So this 18 minus 7 is equal to 0.061 theta. 18 minus 7 is 11, so 11 is equal to 0.061 theta. And if I divide both sides by 0.061, my theta would just be 180 degrees, so to the nearest degree. Great. Next, we're looking at perimeter of a segment of a circle. So what a chord, remember this is a chord here. What the chord does is that it splits the circle into two segments, the minor segment and the major segment. So if we want to find the perimeter of a segment of a circle, how do we do that? The perimeter of the minor segment, if you look at this guy here, so this place here, the minor segment will be something like this. So all I need to find is the length of this chord plus the length of this arc. If it's the major one, it will be the length of this chord plus the length of this arc. So these are how we actually solve questions like this. And length of chord is theta over 360 times 2 pi r, while the length of chord is 2r sine theta over 2. These are things that we've explicitly seen. Example 9 now states that we should find the perimeter of the minor segment PQR. We should take pi to be 3.142. So this is the segment here. So if you look at this place, this is the chord and this is the arc. I want to find the perimeter of the minor segment. Let's solve it together. We know our formula for perimeter of a segment is the length of the arc plus the length of the chord. For the length of the arc, we know the formula is theta over 360 times 2 pi r, and we know that the length of the chord is 2r sine theta over 2. So what are we given? We're told that the r is 5 centimeter, theta is 60 degrees, and pi is 3.142. So let's substitute. That will be 60 over 360 times 2 times 3.142 times 5 plus 2 times the r is 5 times sine 60 over 2. So this will cancel this will be 6, 2 here 1, 2 here 3. What else can we do? We can't simplify it any further. So 3.142 times 5 divided by 3. That will give me 5.237. That's to 3 decimal places. Then plus 2 times 5 times sine 30 degrees. That give me 5. So 5.237 plus 5 is 10.237 centimeter. Centimeter because perimeter is just the length. Let's see if we're correct. Okay, great. So this one's took it to 2 decimal places. We took out 3 decimal places, which same thing as 10.24 centimeter if we did it in 2 decimal places. Great. Example 10 now states that in the diagram, PR is the chord, so this PR, of the circle center O and radius 30 centimeter. We're told that POR is 120 degrees. The angle there is 120 degrees. I want you to calculate correct to 3 significant figures: length of chord PR, length of arc PQR, the perimeter of the shaded portion. I want you to take pi to be 3.14. So this is from WAEC 2004. I want you to pause the video and try it out yourself. Welcome back. Let's solve it together. So the first is that what are we given? We're told that the R is 30 centimeter. We're told that theta is 120 degrees, and we're told to find the length of the chord. So let's say I is length of the chord. Length of the chord, formula for length of the chord is what? 2r sine theta over 2. Great, we remembered it. So that is 2 times 30 times sine 120 divided by 2, which is 60 times sine 60. That gives me 51.962 centimeter. So I now says that we should find the length of arc PQR. The length of arc is what? Great. Theta over 360 times 2 pi r, and this will give you 120 over 360 times 2 times 3.142 times r, which is 30. So this can go here, this can go here, 3 here 1, 3 here 10. So this is like saying 2 times 3.142 multiplying it by 10, and this give me 62.84 centimeter. That's the length of the arc. So notice that what is the perimeter of the shaded region? Perimeter is just the surrounding side. So look at this shaded region. We have the arc. We know the length of the arc already, and this is the chord. we know the length of the chord already. This is like saying that we should find the perimeter of the minor segment, because shaded region consists of the arc and then the chord. So we could just say I. Since we know that the length of the arc is 62.84 and the length of the chord is 51.962, if we add these two, we'll have the perimeter of the shaded region. So we could just say perimeter P is just LC plus LA, and that will be equal to 51.962 plus 62.84. So by the time you add 51.962 with 62.84, that will give you 114.802. So the question says that we should actually correct it to three singular figures. So this one here would be approximately, so three singular figure, that would be 52.0 centimeter. This would be 62.8 centimeter to 3 SF. And our final perimeter, if I wanted to do three singular for this singular figure, 1, 2, 3, so this would be approximately 115 centimeter. So I could just say to 3 SF2. So this is how we solve this particular question. You need to understand what you're solving, and if you understand the question, you won't have to be going up and down the circles. Perimeter is just the length of the surrounding region. You already have the length of the arc, you have the length of the chord. Just add them together, because that's what surrounds this shaded region. Let's see if we're correct. Great. So this example 11 is an application question. It says that a segment of a circle is cut off from the rectangular board as shown in the diagram. If the radius of the circle is 1.5 times the length of the chord, calculate correct 2 decimal places the perimeter of the remaining portion, and you should take pi to be 22/7. Let's look from WAEC 2013. I want you to pause the video and just try this out yourself. Welcome back. Let's solve it together. So what are we given? We are told that the radius is 1.5 times the length of the chord, so that will be 3/2 LC. Right, so there's a chord here. Great. From that information, when I see complex questions, I always try to just break it down, right? But maybe we should just take it a step at a time. It now says that we should correct to 2 decimal places the perimeter of the remaining portion. We should take pi to be what? 22/7. So I want to find the perimeter of the remaining portion, which will be this side, this side, this side, this side, this side, and this side. We already know all of these other sides. It's just the length of the arc that is only remaining. So the length of the chord, if year to year is 22, remember it's a rectangular board, and year to year is 5, and year to year is 3. So the length of the chord would just be 22, which is the entire length, minus this 5, minus 3. 22 minus 5 is 17. 17 minus 3 is 14. So 14 centimeter. That's the length of the chord. So that means our radius is just what? 3/2 times 14. 2 year 1, 2 year 7, which is 21 centimeters. So that's the R. Now that we know that, we know the radius, we know the length of the chord. So for us to find the length of the arc, right, the length of the arc formula is θ/3 times 2 pi r. We need to know what theta is. For us to find what theta is, if this is the chord, right, so the chord would be something like this. Let's say something like this, right? That means there's an angle here, and that same angle is what serves the chord and serves the arc. It's the same angle I'll have used to calculate the length of the chord, the same angle I'll use to calculate the length of the arc. The formula for length of chord is what? 2r sine θ/2. So if this is our angle theta, it should be sine θ/2. So let's substitute. The length of the chord is 14. 2 times r is 21 times sine θ/2. So this would be, I can divide both sides by 2 times 21 divided by 2 times 21 to make this sine stand alone. This will cancel this. 2 year 1, 2 year 7, 7 year 1, 7 year 3. So what I have is 1/3 is equal to sine θ/2. So for me to find the θ/2, what it would be, I know we've not reached this before, but if you have done anything about trigonometry, you know that the θ/2 will be equal to the sine inverse of 1/3, right? So θ/2, if you do sine inverse of 1/3, what would that give you? To do sine inverse on your calculator, you press the shift and press the sine. to give the sign inverse, and then you put the 1/3 in brackets. So I did it on mine. It gave me 19.471. So if I cross multiply, that will be 19.471 times 2. So I multiply this by 2. This gave me my theta to be 38.942 degrees. So that is our theta. So if we want to find the length of the arc now, we can now do this and say length of arc is equal to theta over 360 times 2 pi r, which will be equal to 38.942 all over 360 times 2 times pi times 21. Our r is 21. So I just plug all of this into my calculator. So this is divided by 360, multiply this by 2, multiply this by 22 over 7, multiply this by 21. So my length of arc is 14.279 centimeter. So I know what the length of arc is. So if I want to find the perimeter of the entire shape, that will be easy to do. That will be 22 plus 12 plus 3 plus the value of my length of arc plus 5 and then plus 12, because this is a rectangle. The length of this side is also the length of this side. Therefore, perimeter of the remaining sides is equal to 22 plus 12 plus 3 plus length of arc, which is 14.279 plus 5 then plus 12. So this will be equal to 22 plus 12 plus 3 plus 14.279 plus 5 plus 12. This will give me 68.279 centimeter, and it says we should do it to 2 decimal places if I'm correct. Great. So this will be approximately 68.28 centimeter to 2 decimal places. So these are you solve questions like this. Just know what you're trying to achieve and then use the information you're given to get what you want. Let's see if our answer is correct. Great. So that brings us to the end of this particular video on length of arcs, length of chord, perimeter of sectors, perimeter of segments. If you found this video useful, don't forget to subscribe to our channel. If you have not liked the video, encourage my ministry by liking the video and commenting if you have any question. And I guess I'll see you in the next video. Bye for now.